Said, we're familiar with this, all right? If we're finding the area of a triangle, you sort of learn this in late primary school, it's going to be 0.5 times the base times the height, okay? Now the height has to be, for this to work, perpendicular to the base. It has to be at 90 degrees, all right? So we'll have an example over there in a moment of that, of what we do back in primary school. But we're going to derive a new rule here using right-angled trigonometry. Okay, let's consider this triangle here, okay, this part of the triangle here. I'm just going to pull that out, I'm going to abstract that from our picture there. That's a dotted line that is called H, and this is A, and let's call this angle in here theta, okay? Now, using right-angled trigonometry, we can come up with an expression for H in terms of A. If we're thinking about this right-angled triangle here, this is 90 degrees, isn't it? Because the height has to be at 90 degrees. This is the hypotenuse, and this is the opposite side. So if we're thinking of right-angled trigonometry, we can again think of our SOHCAHTOA. Which one involves the opposite and the hypotenuse? It's going to be the sine ratio. So let's make a statement here where we're dealing with this triangle. Sine theta is O on H. I'm going to write it out properly actually, opposite on hypotenuse, just so we're not confusing them. Now in this circumstance, our opposite side is the height of this triangle here, isn't it? It's the height. So we're going to have H there, and on this side we've got A. A is the length of this triangle. Okay? And so from here we've got sine theta is A on H, which means H equals A times sine theta. H is A times sine theta. Now come back to this formula. This is the formula for the area of a triangle. Okay? Now because we've come up with an expression for H, the expression for H is A sine theta. And so here we've proved that the area of any non-right-angled triangle is half AB sine theta, or half BA. They're not going to matter, order of multiplication is the same. So what this means now is if we have any non-right-angled triangle where we've got this length and this internal angle, the area is half times A times B times sine theta. Okay, we've demonstrated that with this diagram here. Okay, if that's confusing, doesn't matter. Let's move over here to the application of it, and this is going to be the important part. Find the area of these triangles. Well, this one's going to be 0.5 times base times height. We can see that because we've got the base and we've got the height, which is perpendicular to the base. So we're going to have 0.5 times 4 times 5. We've got 10 centimetres and squared. And what does that mean when we're talking about area? It means how many square centimetres? They're 1 centimetre by 1 centimetre. Are going to fit inside that shape. 10 of them. Okay. Now here we get into the application of the new stuff. All right. So it doesn't matter what we label A and B, and this is the angle we're trying to find. We're saying find the area of this triangle. Well, the area is going to be 0.5 times 12 times 13 times sine 37. Let's crunch that. We need to make sure our calculator's in degrees. The angle we're given is in degrees. 37. And I've got 46.94, which is 46.9 meters squared. So in this test coming up, guys, you're going to have to switch between both radians and degrees. You're going to have to be able to do both. And just look in the question, what's it giving you? Is it giving you degrees or is it giving you radians? All right, let's move on to have a go at this 6A. Thank you very much.